For the second keynote of the day. It's another keynote by Siemens, and the title is Using Blockchain Technology for Cybersecurity. Our keynote speaker for the afternoon is Prabhakara Kasinathan from Siemens, in short Prabha, that you know him already from the challenge, and he will also continue working with you on the challenge. Nevertheless, he will also be super happy to answer your questions to his talk, and it would be great if we have some 3-4 questions at the end, so you can think already which questions you would have for him. Prabha is a research scientist at Cybersecurity Technology Siemens, at Siemens AG in Munich in Germany. He's working in the field of IoT security since 2012, and he has published in security conferences such as ACM, ZigZag, and SRX, and in IoT conferences such as EWSN and WIMOB. His current research interests include Internet of Things security, blockchain, and cloud security. He works in international and European funded projects like Cybersecurity for Europe and a comprehensive cyber intelligence framework for collaborative manufacturing systems. So it's a great pleasure to have you today, Prabha, and as usual, for those people joining us via the online media, we have the Slido. So please also ask a lot of questions in the Slido, because the presentations are always more interesting when we have some interaction. So now let's look at the trailer of Prabha, and then I will hand over to you.
Securing distributed and collaborative business processes that involve industrial Internet of Things or services in a cross-organizational context is a challenging task. It becomes even more difficult when the involved parties do not trust each other completely. This keynote presents some real-world use cases where there is a need to enforce cross-organizational business processes without a trusted third party.
Great. So yeah, great introduction, and now we're looking forward to your talk, and we are listening to you.
Okay, thank you for the introduction, Oliver. Can you give me a quick feedback? Everybody can hear me? Can hear me? There?
It's working perfectly.
Okay, then great. I'm happy to hear. So thanks a lot for giving me this opportunity to give a keynote on the topic, can blockchain help securing Internet of Things or industrial Internet of Things? And also for the great introduction from Oliver. I don't have to introduce myself again. Shortly, you can call me Prabha. And in today's talk, I would like to present who we are in the sense from the Siemens department and what kind of applied research we do at Siemens, at least in my department, and finally to answer your questions and answers. So we are part of Cybersecurity Technology, which is a central research and development department for other Siemens businesses. And within this technology field, this morning there were two speakers, Santi and Tiago, and they introduced also a similar slide that I have here. Here we represent, let's say, people from all over the world, and we have different departments focusing on specific areas in different parts of the world. And I work at Security Architecture Department here in Munich in Germany. And Santi and Tiago are working security lifecycle team. And in total, we are around 150 cybersecurity experts working to improve the cybersecurity resilience within Siemens and to help our businesses. And we have more than 30 years of experience in cybersecurity research and technology consultings. And we are one of the main important standardization driver also in multiple industrial communities. So with this introduction, I would like to jump into the keynote organization. And here in this keynote, you will hear me about different use cases that we are currently tackling as part of the funded project. And therefore, I will give you a very brief introduction to different funded projects that I'm working and what type of topics they are focusing and what is Siemens doing there. And later on, to present the challenges which we face in addressing those use cases and the requirements coming out of these use cases in terms of security, as well as their relationship between Internet of Things devices. And finally, a high-level overview of our approach. And then finally, as participant, what could you take away from this keynote? So that would be more interesting. When to use blockchain? Is really blockchain helpful? And I hope we can answer all those questions at the end of the talk. So to start with the use cases, I will go with a very high-level introduction to one of the funded projects. And here you see a European Union cybersecurity competence network, which is formed by different pilot projects, starting from ICO, Concordia, Sparta, and Cybersecurity for Europe. And the European Union's objective as part of Horizon 2020 funding framework was to create these four big cybersecurity projects to create a competence network so that there can be collaboration to enhance the cybersecurity capabilities within the European Union. And you can see here the numbers as quick stats. It has been funded quite heavily, and more than 160 partners all over from the 26 EU member states are involved. The main idea is to design, test, and demonstrate potential governance structures for the network of competence centers, and as well as to ensure the adequacy and availability of cybersecurity as a whole, and training as well as a common open standards for other people to use. So here, I'm going to give you a use case that Siemens is tackling as part of cybersecurity for Europe. To note, Siemens is also part of Concordia project as well as cybersecurity for Europe, and I work at Siemens for cybersecurity for Europe. So some key facts about cybersecurity for Europe. The funding period started at 2019, will end in July 2022, but it might be extended 6 more months. And we have 43 partners spread along in 22 countries. You could see here the map showing the partners where they're coming from, and several technology and application elements, for instance, from 9 vertical vectors, such as finance, supply chain, healthcare, transportation, marine transportation, and so on are being focused in this project. And at Siemens, we focus on compliance and accountability in distributed manufacturing. So what does it mean? Let's take a look with an example. So here in the use case one, Siemens builds, let's say, big power plants, and for different regions or countries. Here, before Siemens can really build a compliant power plant based on the regional rules and regulations, there must be a feasibility study conducted. And then there's a sequence of approval flows, starting from the internal approvals. And then once a feasibility study is really completed, then the design can be published by Siemens. And here, there is a certification body involved. It depends on the region. For instance, if it's in Germany, an organization like TÜV, for instance, TÜV Rheinland, usually approves this process. And then it makes sense that, okay, now the design has been published, as analyzed to fulfill the requirements and the regulations of a particular country, and then people can build parts required for the power plant. And all this is done so far by paper trace, meaning PDFs and Excel sheets and design documents are printed perhaps or sent via email, and then this complex process takes place. Once the design is there, then the suppliers, for instance, of a part from a power plant can actually produce the parts. My PowerPoint has some issues currently, but it works. I'm happy. So once the supplier one produces a part, then from here you could imagine a supply chain where part A to B is produced and then integrated in the supply chain. And overall here you could see that in the factory floors, different end equipment like industrial IoT devices can be used to fulfill the process and the design that has been created, and also to make sure the quality and the provenance of those parts are maintained based on the approval that has been done. So in order to do this, we need data from those devices to then manufacture or integrate those parts. So here there is a clear mix between different nations are being involved. For instance, Siemens, suppliers, certification bodies, and there is always a concern if something bad happens, if there's one party responsible for a defect in a product, then it is a huge process to understand the root cause analysis and to find really where the problem started. So in order to digitalize this, where there is an interaction between Internet of Things devices and there is a use case where different organizations are being involved. And of course, when different organizations are being involved, they might have different mutual interests and they might not completely trust each other in a way. When a product is really a defect, then they always try to maybe find issues where they could pass the blame to another person. So how can we avoid all these problems is one of the challenges, and this is what we do in this project. And to give a second example, I would like to highlight the comprehensive cyber intelligence framework that is being created for resilient collaborative manufacturing systems. Here in this project, this abbreviation is called Collapse. In this project, 13 partners all around Europe are being involved, and 3 major industrial partners such as Philips, Renault, and Collins Aerospace are involved, and they provide us the use cases. And Siemens acts here as a technology provider, where we help them to address their use case requirements by developing technologies. And in this project, the use case focuses on secure remote maintenance via an approach that you will be seeing in this talk. So it's called workflow-driven security framework. So the talk mainly focuses on this use case from now onwards. And to introduce the use case itself, I actually have recorded a video together with the colleague that we work together with Collins Aerospace, and this talk is going to be presented in the upcoming IEEE Blockchain 2021 conference in Melbourne, Australia, via online. But so here for you, I'm going to give a quick peek into what is going to be presented there. So with this, I play a very short video, and I hope you are able to hear that properly. So on the right-hand side, you see me and David going to play the video now. So you will hear Davide from now onwards for next 5 minutes.
Project both as and technology provider. On this research with my colleague Valerio, talk about factory so both as nowadays providers used in the plants. Today we're going to talk about for manufacturing need regular update and configuration changes. Nowadays, provider about manufacturing need revenue provider by trained and which comes from the original equipment manufacturer or OEM. Third-party manufacturer brings some concerns about manufacturer. So it's highly trained confidentiality and integrity, about sensitive or intellectually property relevant data, especially about factor. So sensitive or about 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 sensitive or about
Definitely. So I saw the video now. Do you hear me now? Can you tell me if you can hear me?
We can hear you, yes.
Yeah, I think the video playback somehow didn't work perfectly. So I will continue with the talk myself here. Yeah, I see the point. I think right now it's easier to explain it myself, I think. So yeah, let's go ahead. Sorry, Davide. Okay. So here you're seeing the use case where the manufacturer have different concerns. As for example, in this case, Collins Aerospace or even Siemens in other factory scenarios, they have concerns like whenever a third-party engineer who wants to do a maintenance on devices that are present in our manufacturing floor, then the concerns are such as sensitive data and confidentiality information available inside the power plant should be protected. And the software integrity, for instance, if there is an update brought by the maintenance technician, needs to be validated, and therefore there should not be any kind of malware injection or anything of that sort to get inside our factory network. And from the perspective of the equipment downtime, when there is a remote, then the advantage actually that is you're able to do it without full operation that is happening in the industrial floor. And finally, also there is a strict compliance process that are involved in each organization. So therefore, that also taken care of. But on the other hand, let's say from the perspective of from the perspective of them, meaning in this case, the engineer who comes into the other organization's plant and provides a technical support, they also have obligations, or they want to always protect the data of the customer, and also they need to be accountable for anything that happens inside the plant. And therefore, the technician who's operating inside the plant should have, let's say, proper certifications so that he or she is able to handle the equipment and also minimize the time that is required to fulfill the operation. And most importantly, technicians are required to fulfill strict defined procedures that the technician should fulfill. So here you see the different concerns, but both of them are concerned about different problems. So one is the common objective that nobody wants to harm each other, but then again, they want to prove later on that the OEM did not bring any bad stuff like malware. And also later, if there is a malware, then the OEM should be able to convince later that it's not because of them. So how could we mutually solve this problem? And there could be, again, other organizations who are maintaining, who wants to see what is happening from the auditing perspective. So here you see a very high level view of the industrial floor, or the different layers. You have shop floor, manufacturing floor, and the enterprise. And the shop floor, you have industrial machines with sensors. And this is the color pink you see is the boundaries of the manufacturer. And on the right-hand side, you see a WWW boundary, which means it's outside the boundaries of the manufacturer, which is the internet. And in the internet, you obviously have different companies like OEM who wants to do a remote maintenance. Here, the high-level objective is to enable secure remote maintenance or access to the equipment by using the approval process, or other objectives which are defined later in details in the paper that will be published. The high-level objectives are, for instance, ability to model and design and enforce the workflows, and then access to the services are provided by using the least privilege principle, and always logging of these actions are recorded in a mutable way, so that once if there is a problem, if you're able to go back, and you should be able to prove that the person X or Y has done this and this steps. And from the system integrity protection perspective, only validated and authorized application can execute. So this means there needs to be some kind of formal guarantees before we enforce these requirements modeled and processed, modeled and executed via the workflows. And here you see that the different flows where data could go from outside the company premises to the inside premises through firewalls, and how the maintenance request can first go into the request or the control center in the enterprise level, and then from there, later on, once the appropriate permissions are granted, then the access to the end machine is granted. So for the proposed approach, have to switch to the other presentation. So here you see, okay, give me a second. And okay, here we go. So now we have learned the use case coming from a real industrial scenario. Manufacturer Collins Aerospace, thanks to them, and thanks to Davide for helping me and to present this in this future IoT keynote. So if you put that into a sequence of steps, then it looks like this. So there's a maintenance technician coming from the OEM, and there's a plant manager who then first approve whether you have proper credentials to operate my machines inside my manufacturing floor, and so on. And you see that later on, once you also want to enter into the different layers of the industrial network, then you need to follow a strict workflow or business process. And this is already defined by the plant manufacturer, and is provided to the technician. He should obey this, he or she should obey this to really access to the final. And see that, okay, if you do those steps, at the end of the day, the properties that we would like to have are something like we need to have accountable mechanisms, such that whenever a technician makes a request, it is recorded in an immutable way. And also when the manager approves it, it is also needs to be recorded in an immutable way. What is immutable? At the end of the day, you should not be able to change the data without being detected. And if in the general setup, in most of the remote maintenance scenarios, the applications and the software solutions that exist may provide most of the security guarantees that we have, but most of them are centralized and controlled by one particular organization, either in this case, the plant manufacturing organization, or by the maintenance organization. So in this case, you're not able to fully guarantee that the administrator or their privileges that they have, with that they are able to change some details. So here you could already see that there's a need for enforcing a distributed trust. So how can we do this? This will be the set of challenges, and how we solve is what we will see now. So, okay, there's a little bit of delay. Okay, so as we noticed in those two use cases, we have workflows. A workflow describes a set of tasks that must be done in a particular order. And also we need to make sure that the workflow integrity, meaning the guarantee that the workflow is executed as described, must be maintained. But the real catch is basically there are different organizations, and these are distributed workflows. Part of the workflows are done by a particular organization, and part of them are done by another organization. And here, each of these organizations, people might want to say that, hey, I want other organization obeying my rules so that to access my resources. And also at the same time, I want to obey the conditions that I have agreed upon, meaning from the other perspective to access others' resources. And they also sometimes have a common feeling that they do not want to have a single trusted third party who would host this workflow management service. And this is how it is traditionally done nowadays, to have this nowadays. For instance, for secure and all those cases that we have seen, having a um, centralized trusted third party means too much power, and you are able to do whatever you want at the end of the day as a maintenance admin of that trusted organization. So how can we do this? By protecting also confidential data, so that you are able to share only data that you want to share with other people in a distributed way. So these are the core ideas, and if you break it down, you could then break it down in terms of 6 different categories. For instance, from the workflow specification modeling perspective, how can you make sure that the confidentiality aspects can be preserved? And how can we enforce those workflows in a distributed environment? And how do we make sure that the interoperability is taken care of, and also at the end of the day, it should be usable? And you might notice that during executing of workflow, there might be errors, and how can we recover from those dynamically? And I noticed there are also IoT devices being used, and they also play a part on top of human involvement in approvals. At the end of the day, we need to also accountable and mechanism, meaning an audit trail, which then can help us to track if there is a problem. So the approach is based on blockchain as a backend for having accountability purpose, workflow-driven security framework, which involves certain components to help us model and enforce workflows. So by merging them both, we are able to get all those properties and solve the challenges. And as a hint, this topic was my PhD topic, which I defended last year. With the title Workflow Aware Access Control for Internet of Things. And here in these two youth-funded projects, we are extending that approach to solve different use cases. And as was more generic, and it can be used in different use case scenarios. So now you might have a questions. Okay, how can blockchain help? What does it provide? So blockchain is not really Bitcoin. It's a different misconception. So blockchain provides, in a sense, decentralized trust, integrity of the data, and accountability, and also control. So party do not control everything. And just a couple of points. I don't want to go into the details of how blockchain works, but basically, in industrial context, we are talking about permission blockchain networks, meaning in order to participate in a blockchain network, there's a consortium of organizations, and they form the network, and they allow participants, so that now it's not completely public, but still within the group of those organizations, you can then restrict who has access to a particular set of data and so on. And at the end of the day, blockchain is basically a choreography of established computer science and security principles, where there's a cryptographic hash chain as the building blocks, where you provide data and they are hashed together using certain hash algorithms. And then whenever somebody wants to authorize a transaction which contains some data, then they are bound with the cryptographic identities, which are then always provided by public-private key pairs. And then for the distributed agreement perspective, here we use the distributed consensus peer-to-peer algorithms, and they provide distributed state replication in terms of practical and fault tolerant, or using crash fault tolerant consensus algorithms. And finally, on the top, we have the business logic implementation using smart contracts. Basically, they are code that are agreed by different parties before they are deployed into the network. And so that whenever a transaction is being published, authorized peers can state that this transaction is valid, meaning not only one organization is able to approve a transaction, multiple organizations approve, and the majority is taken into consideration, or it depends on the distributed consensus algorithm. So now we have learned the advantages or learned how blockchain works, but let's also see the disadvantages of having a central trusted party. So too much power, as I said before, and inside attackers can go unnoticed by changing or log data, and there's a single point of failure, and also in some sense there's a scalability limitations. But also on the other hand, there's an advantage where single owner means full control, easy maintenance, and restricted access to users' data. So now coming back to the workflow perspective. So I talked a lot about workflows, but now I want to give a quick introduction to a concept pretty old, but still pretty powerful, called Petri nets. Petri nets are labeled state transition system, which then has places represented as circles and transitions represented as rectangles. And here you have as tokens, and tokens are represented as circles here, and they can contain arbitrary information. And basically, with Petri nets, you're able to model complex processes, and with the reachability analysis and reduction techniques, you're able to quickly validate certain workflow properties. For instance, if there's a deadlock, you're able to find that. If there's a place that you want to make sure that it's not reachable because you need to have a potential guarantees in the workflow that it's this unsafe state and safe state and so on. And you're able to reach all those, validate all those properties such as safety and liveness beforehand and then deploy them. So also they provide features such as hierarchical Petri nets, with which you're able to model complex workflows. As you can see now, I just did this transition. You are able to see here, once I make the transition, these two tokens can be consumed by the transition and provide as outputs to the output. So it's very easy for a non-technical user to understand how the workflow works and also to play with the workflows. There are a couple of extensive research tools available already, and therefore you're able to model and validate those properties by yourself. And there's quite some open source support as well. So now let's see how we can model one particular step using workflow, using Petri nets as part of the workflow-driven security framework. So we noticed that there was a maintenance technician makes a request, and here we can model the manager on the left-hand side as a place, and maintenance technician, the approval information can model as a token. You're able to validate certain properties that are encoded in the tokens. And this is how you're able to validate that the manager's signature is there, or order information coming from the maintenance technician is coming from the authorized list of OEMs that I approve as a manufacturer, and so on. And therefore, as a whole organization perspective, you're able to model them. And if two other organizations have their own internal workflows, then they can be merged together with the synchronization concepts. And this is why it's really a good tool for this particular use case, or this particular general approach where we want to solve these use case problems. On a high level, you can see that not everything can be automated. First, there is a negotiation phase where different organizations sit together and then design the workflows. What do you want to agree with, and what I want to agree with. This process is quite complex, cannot be automated, but it can be simplified by using um, activity diagrams, which are easy to understand by everybody. And from the activity diagrams, then you're able to translate them semi-automatically to Petri nets. And from there, we have developed, as part of our research, some tools which then are able to develop or create templates of smart contracts. So, meaning by using all the Petri nets validation features, you're able to date the properties that you want to achieve. And once it is satisfied by everyone, then you're able to develop, export a smart contract template. From there, then you're able to publish the smart contract template and execute them. And so we have some tools, applications, which then helps you to interact with the real world IoT devices, as well as parallelly to call smart contracts. And it's the high level platform that helps you to achieve those interoperability. So if you put it in the layers, then Petri nets are used for modeling the workflows, and smart contracts derived from the Petri nets are used for enforcing them with the help of blockchain. So at the bottom, there's a immutable blockchain network. In this case, we used Hyperledger Fabric, which is a permission blockchain network. And on top of that, as I said, from the model Petri nets, we derive the smart contracts, which then represent one-to-one business logics that has been modeled, and we deploy them in the network. To interact with that, we have the workflow layer, which is the Petri nets workflows, and this can be directly imported into the application that we have developed, which is what you see on the right-hand side, which is providing the graphical user interface, pretty intuitive, easy to use for the users, with authentication, authorization components as part of their organizations that can be integrated using standardized protocols like OAuth. And from there, you're able to interact with the workflow that you have defined. And the workflows basically trigger the smart contracts and the respective smart contracts. For instance, if you're in a step, then this steps allows you to query a smart contract to publish some information. Then at this particular step, you get the right permissions to query the smart contract. And then once you pass that step, based on the least privilege principle, then those permissions revoke for you. Similarly, based on the step that you are in, you're able to access particular services as part of the Internet of Things services or devices. This is how we achieve um, the solution. And now you see here a sample high-level workflow that has been modeled for the paper that we published in IEEE blockchain. Basically here, the workflow starts by initializing, and then there are a couple of actors involved. And first, in order to start the request, there must be a device with issues. And then the shop floor technician usually identifies this and makes that, okay, here there's a problem. Then we need the next step where we need to create the maintenance order, and this is done by the manager. And from the manager, then the request is sent out to a technician who is outside the company. From there, the second approval is there. Once the approvals are granted appropriately, then and finally in the main page to access the PLC or any other devices through services that are exposed in a way within the network. And finally, to complete the process, you should have done all these steps in a proper sequence. Therefore, you're able to prove at the end of the day to somebody that you have completed the workflow as it is defined. And then you reach the end state. Now you may ask how I could then see this in the application. So the application looks like this. So for this two-step scenario, so there is application shop floor technician, device issue, and then approval one, maintenance order is there. So the application then consumes the Petri nets and dynamically changes the state on the information that is available inside the network. And here you see there's a device issue found, and the software technician has provided his signature or her signature, and the approval one transition checks that the signature is true. And then here you see SC API, meaning smart contract API, calls an approval method inside the smart contract and provides these two input information, issues and the signature token as input for the smart contract. And here fields where you can enter tokens as a, and here only a user or authorized user at this point in time can provide information. And once information is available, then the manager or other authorized user are able to fire the transition, meaning move the workflow to the next step. And here you could see that this kind of workflow application can be deployed in a parallel in different organizations, so they can all work together in a synchronous way. So we will get into the deployment now. So we look at the architecture now. Let's assume that we have a couple of organizations, for instance, manufacturing or OEM organization, and then a compliance monitoring organization, which then look the compliance process of how remote maintenance perhaps should be done. And as I said, we need the most important part is it's not happening between one or two, but more than a couple of organizations. So it's cross-organizational. Cross-organization is involved for executing this workflow. And as an we have the workflow application is installed in the manufacturing application, and as well as in the OEM organization. And once the application is available and the model workflows are there, then the maintenance technician and the shop floor manager or the enterprise manager can download this workflow and then start executing them. So here you see the workflow manager who then pushes this and then makes sure that in the IAM, he configures who is authorized to execute the workflow. And now you could ask a question, okay, so everybody has their own instance, how they communicate with each other, how do you make sure that the state information is synchronized? And exactly, you might now have an answer already. We use block for this to replicate the state in a single source of truth to everybody at the same time. And also to make sure that when a step is completed, it is also validated by other organizations, which has been agreed earlier. So the model workflows is enforced in a distributed way. And at the end, you could see that we are able to satisfy all the properties and the requirements that has been laid down by the organization Collins Aerospace. And within the context of Collab's project, we are developing and experimenting access to edge devices, for instance, industrial machines through software-defined network, and firewalls will be then controlled by API-driven services. So this is an ongoing project, and if you're interested, you're invited to look at the paper and also join us in the conference and ask questions. But now already you can ask questions at the end of the talk. I think we are close to our end now. Let me see. Yeah. So the final takeaways, you could then ask, can blockchain now help securing IIoT devices? So I think it depends. When you have certain requirements, such as distributed organizations are involved, and there is a lack of centralized trust, and you need to enforce certain conditions that are agreed between different organizations. But as I said, there is no trusted party that everybody can trust, and you need to have accountability mechanisms. And at the end of the day, those IoT devices also need to have some kind of tamper-proof hardware, so that you are able to establish the trust that the information that is coming from this device is actually coming from this device. If not, then everything can be faked. Whatever is information is inside the blockchain can be still changed because it may make us a different product. So if you have all those requirements in place, and if you have a use case that fits, then blockchain fits, because usually having them integrated is a complex task, and it requires lots of resources than going for a centralized workflow management systems. So as I said, there are pros and cons again for each and every solution we present. Here are the pros. I think I went into the pros quite detailed in the talk. From the cons perspective, I think when we describe PetroNet workflows, they're not always error-free by themselves. For instance, if you, from the design phase, make some mistakes, then these errors will also be in the PetroNet workflows and therefore in the smart contracts. So we need to be vigilant on that. so that we need to have like a four eyes principle, that one person really reviews the workflows that you have designed and before it's being approved and deployed as a smart contract. And these workflows can get big and complex. So at some point in time, if so many actors are involved, it can get cumbersome to manage. I think it's generally applicable for all scenarios. And finally, changes in the business logic means you need to go back to the modeling stage, validate all those properties again, and then redeploy. So it's not easy as you can do as a code. Just open the smart contract and then modify some methods or add some methods. Then it means that the workflow logic has changed and there might be some problems which you have missed to validate in the workflow modeling stage. So these are some of the time-consuming cons, but still provide security guarantees that you want. And as a result, I'm very happy to present this, because now with this work, we have moved from one research phase to validation phase, where we are now testing our framework by deploying them in the actual laboratories of Collins Aerospace, and we have developed a blueprint architecture, which has been presented in the IEEE blockchain paper. And we also made sure that we wanted to evaluate whether this proposed method works in terms of usability perspectives. So we deployed more realistic network. So a couple of nodes in the US and a couple of nodes in the European Union. And then we tried to evaluate how many transactions can be made on this network with the smart contract that we have, and with the workflow application layer that we have developed. And we were able to achieve, as you can see on the table, 39 transactions per second, and as writes, and average latency was 0.6 seconds, which is pretty good. And on the reads perspective, it's quite high, 111 transactions. And then 0.17 seconds as an average latency. So this means it is generally applicable for generic industrial use cases, but might not be sufficient enough for high transaction-oriented financial use cases. For that, you need to optimize the backend databases and do much more optimization on the Hyperledger network. And as a future step, we wanted to extend approach by using trusted execution environments, and to make sure that the end-to-end security is achieved, and also to formally verify the software guarantees that that was required during the requirements phase. So that's in short about what we do. So the key message here is Siemens does applied research, and thank you really for your attention. A hint here, as I said, we have more than 30 years of experience, and as Santi also mentioned in the earlier call, we always look for talented young people. It could be master's students, a master thesis, or PhD thesis, or full-time research scientists like me. So these are basically the 17 open positions currently available all around the world. So if you're interested, look at jobs.siemens.com. And those 8 parts of cybersecurity technology. So thanks a lot for listening. And right now, I would like to take questions. And this is my contact information if you would like to reach out to me later.
Perfect. Thank you very much, Prabha, for the very interesting keynote. While the audience is preparing for the questions, I ask maybe the first one. So is scalability an issue when using the blockchain? And if so, how is it resolved?
So in terms of deploying more nodes and creating more computational power, it's not an issue, but it depends on the logic that you want to implement. So if you, because it depends on the blockchain platform that you use. So if, for instance, in Hyperledger Fabric, it depends on the endorsement policies. For instance, if a transaction is true, then you have to define how many endorsements you need. And if you scale it up, then this will have a direct impact in the transaction throughput. So really, you can play around with this configuration, and it depends on your use case. So it's not easy to say a generic answer. But for our use case, it fits.
Who has a question? Fabian. We have Slido questions?
Yeah.
Okay, perfect. Yeah, then I can.
So one of the anonymous questions is from Dr. Reinden. But anyway, first one. Which kind of blockchain are you using? In parentheses, IOTA. I think as an example.
So I think I mentioned it. So in this particular use case, we use Hyperledger Fabric as a permission blockchain system, or that we use within this use case to solve the problem. Does this answer your question? So IOTA is another one. We use Hyperledger Fabric.
The second question is,
So the question was, what is the benefit of using Hyperledger Fabric?
Can you repeat the question? What is
the benefit of using Hyperledger Fabric?
So a couple of advantages from the industrial context. You have a permission network. So as a consortium in the beginning, you are able to onboard certain group of people, and you can extend this or use a number of organizations. So here, first of all, you restrict the amount of people having access to your information. And within these organizations that are part of the Hyperledger Fabric network, there are a couple of enterprise grade features that usually we need in terms of restricting the confidentiality of information as much as possible. So there are channels where a subset of organizations that of the network are allowed to be part of a channel, and within these channels you have also other concepts such as private data collections, where you store confidential information off chain, meaning it's not all part of the public, not really public, let's say in the channel blockchain network, but you still have an off-chain database where you actually provide the data and then just provide for accountability information, the hash of the data, for instance, on the blockchain. And much more. So for instance, Hyperledger Fabric allows you to program in different programming languages. So it brings much more flexibility. But if you want to look at the details of why Hyperledger Fabric is better, then I would recommend to read a couple of our research and as well as their documentation page.
Let's go to the next question. Is there a real application of a blockchain in practice at Siemens? In practice or at Siemens? If not, when do you see the first real blockchain application at Siemens?
That's a very interesting question. So that's a very interesting question. First of all, so to answer this, it's difficult to answer all the details that's happening inside Siemens as a whole, but what I could offer you is to look at our Siemens website and look for C-Green as a product which is being piloted now and will be released soon. C-Green is a product coming from Siemens to track carbon footprint between organizations in the supply chain. And we use a kind of blockchain, but all these details will be available when it is released openly to the public. I can only give the information that is already existing on the Siemens website and as part of the press release. Hope this answers your question.
Okay, thank you. Next is the following. I think this is the last question. Actually, it has two questions. I think it should be how is IoT communicating with the smart contracts? And how are they securing the channel of communication between them?
That's a very good question. So I did not in the talk that IoT devices are directly communicating with the smart contracts. It can, but in our approach right now, we have our orchestration layer, which is the Petrinet's workflow layer, and the Petrinet's orchestration layer communicates with the IoT device, for instance, and then provides information back to the smart contracts in different steps. But can also be programmed in a way that contracts can query the information. Then it means we need to make sure lots of communication channels are opened, and these IoT devices needs to talk to to the smart contract methods and so on. So you could do in theory, but in this version of the development, we did not do this.
We don't have any questions in the Slido. Let me check once again among the audience. Do we have any questions? Yeah, then I hand over back to Professor Paul.
So your question is, in the whole process, the step that I showed, which is the most complex part, correct?
Exactly, yes.
So so getting the requirements from the partners and modeling them, it's a time-consuming part, as well as once you have the requirements and the modeling and the requirements are being satisfied, later on, the next complex part from our research was to also bring up this blockchain network between cross organizations. So in this case, if there are a couple of different organizations, then to onboard the network and the maintenance, let's say, of the network also is quite some task. Technically speaking, the first phase is the complex one, but the second one is more development, DevOps complexity.
Thank you very much. And Akin has another question from the chat.
I think this is also a follow-up from the previous question. Is the communication intercepted by a man in the middle potentially dangerous?
You're right. So there is always a possibility for having a man in the middle if it's communicating over the internet. And for this reason, we need to always make sure that the endpoints talk with each other securely. For instance, you could use TLS or other communication protocols based on your infrastructure and the legacy devices as you have. You need to make sure that the communication between different microservices, as I call it, need to be protected. Yes, this is important. And as I said, we don't also want to have software level protection. This is why I said at the end of the talk, in the future, we also want to make sure that really we want to use end-to-end security in the sense, meaning from IoT level using trusted execution environments as well.
Very good. So if there are no more questions, let's thank Prabha once again with a warm applause. Very good. And then we will go upwards with you again to the next floor, but I will just briefly show. Let me just see.
Thanks a lot for wonderful questions.
Yeah, thanks. Okay, so good. yeah, so this was now the cybersecurity keynote, and then we're continuing working now on the challenges, and this was the last slide. Okay, perfect. So we continue working on the challenges, and the idea is that we start here at 5:30, and then we go to the city center where we'll have a city tour tonight, which will start at 6. And so yeah, so let's meet again upstairs where the coffee is also waiting, and yeah, see you in a couple of minutes there.